We'll now move on to our drawing tips. So we'll begin by using the File, Make Drawing from Part option. This will automatically populate the view palette down the right hand side with our standard views. You'll notice we've got Auto Start Projected View switched on, which means that when we drag in our first view, we automatically switch to projected view, and we can project off our main view in either first or third angle projection. I want to change the sheet scale now, so I can do this from the status bar. I'm going to use the new user defined option and set my scale to 2/3. Now in terms of moving views around, we can grab hold of the bounding box that surrounds the view and drag it. But if we're inside the view, it's more difficult. If you do want to move the view around and you're inside the bounding box, use the Alt key. If you want to move the one view and all views relative to it, use the Shift key. From the flyout menu, I'm going to use the Projected View tool. To break the alignment of the view, I can hold the Control key and place my view down like so. The S key also works at drawing level. So here I'm going to launch the S key and then select Section View, and we'll section through the centre of our hole. Now to break the alignment, I'm going to hold the Control key again. A nice option within the section view is to use the emphasize outline. This just displays the cut face edges with a thicker font. We can reverse the direction of the section just by double clicking on the section line like so. Next up, I want to rotate this view around. Now rather than keying in an angle, I'm going to select an edge, and I'm just going to say I want that edge to be my horizontal edge, and it will rotate the view for me. The design library is a good place to store notes. I'm just going to drag and drop this note on my sheet. Now you'll see that the note isn't connected to the view at the moment. Now to do that again, what I'm going to do first is to double click on the view, and that locks the view focus. That means wherever I place this note now, it's automatically going to be attached to the drawing view. So you'll see that as I drag the view around, it moves in unison. I'm also going to select both of those notes and then use the group option on the right click menu to group them together. Next up, we're going to create a detail view. So we'll use the S key again to access the command. Now the detail view will automatically select the circle tool for you. You don't have to use a circle, you can use any closed shape. So here I'm going to use the rectangle tool. We draw a rectangle around the area that we want to capture, and with it pre-selected, go to the Detail View command. A nice option within the Detail View Property Manager is to show a jagged outline. So that just shows the cut faces with a jagged outline, making it clear as to what's going on. Next up, we're going to go and dimension this top view. So we'll use our Smart Dimension tool to do this. We select our entities, and we can use the Rapid Dimension tool to place the dimension very quickly to the left or the right of our view. What's nice about this tool is you'll see that it'll lift the dimensions up to house the new dimension. Next up, I want to dimension to the virtual sharp on this filleted edge. To do this, I right click, find intersection, and then select the two edges that intersect with each other. Okay, now you may find that when you edit your drawing, your dimensions can become a bit messy. To align them again, you can select them all, and from the dimension palette, use the Auto Arrange Dimensions tool. We'll now move to our front view. For this view, I'm going to dimension it using the new Chain Dimension tool. I'll pick my starting point, and then I'll build up a stack of dimensions like so. Now I realise I want baseline dimensions instead, so I can right click and convert them to base at the click of a button. Another dimension tool that we have is the Ordinate Dimension tool. We pick our start point, and then again build up a stack of ordinate dimensions like so. Here I'm intentionally avoiding the tapped holes. Now if I end my tool, if I want to add some more ordinate dimensions to it, I can right click and select add to ordinate. And it's actually possible with ordinate dimensions to add to ordinate with a detail view. Next up, we'll just add some radial dimensions. Okay, now I want this dimension here, this diameter, to be a linear dimension, so I can right click, go to display options and click on display as linear. For my radius dimension here, I want the text to be horizontal. So to do that, I can select the dimension, go to the Leaders tab in the Property Manager, set up a custom text position and just change the text to horizontal. That will just affect the one dimension that I'm working on and not all of them. Now I can access the palette, and here I'm going to add a tolerance. Now rather than this being a radial dimension, I want it to be a diameter, so I can right click it, go to my display options and display as a diameter. Now I want that same tolerance applied to the 63.5 dimension. So to do that, I go to my dimension palette, and rather than keying in the values again, any recent customizations that I've done to dimensions will appear in this recent box. I can also save these away if it's a thing that I do on a common basis. I can also launch the format painter, and that will allow me to copy the format of one dimension to another. So you'll see here my copied format has been applied and the tolerance and the text position is pulled through. I'm now just going to finish this off with a few hole callouts. To save my document away, a keyboard shortcut that we can use is Ctrl+S. We'll then just save our drawing away, and then we'll move on to our assembly tips. So we'll start off our new assembly, and then we'll browse to the first component that we want to bring in. We'll use the green tick to position it. This will align the component origin with the assembly origin. We'll use the S key and launch the Insert Components dialog. I'm going to select two components to bring in now. We'll go for the gasket and the gasket cover. Now I Control select them, and that allows me to place my first one in, move on to the second one and place that in like so. Now my gasket cover is too big at the moment and I need to modify it, but I want to make sure I just modify this instance of it. To do that, I can right click on it and choose the Make Independent option. This will allow me to save it away as a brand new name without modifying any of the other instances of it. And you can see it updates in the tree. I need to reduce the size of this by 2 inches. So I'm going to pick on the driving dimensions, and you'll see that they're in metric at the moment, but if I type in -2in, it will convert that to metric for me on the fly. Now we need to position our gasket, so I'm going to launch the Mate tool. Now I need to select that back face. To do that, I can hide faces away using the Alt key within the Mate command. And then I can make my two components coincident. To select the small side faces, I'm going to use the G key to launch the magnifying glass. And we'll make the top face coincident as well. Now it took me 3 mates to position that component when I could have done it in 1. A mate that we don't use that often in SOLIDWORKS, which we probably should, is the Profile Center mate. Just allows me to select 2 faces, and then from the Quick Mates toolbar I can choose Profile Center, and it will just bring those 2 faces together with the center point as reference. I can rotate around the global coordinate system, or I can build in an offset with this mate type. From our recent documents list, I'll open up this set screw. Now when we make this in our assembly, this surface here is going to be concentric, and this surface here is going to be coincident. Now I can get those 2 mates to happen automatically by building in a mate reference. I select mate reference from my dialog, and I pick the common edge between the concentric and coincident references. And that's it, done. We'll rebuild and save the document, and then we'll close it down, and then use the Insert Components dialog to insert that into our subassembly. Now anything cylindrical that I hover over, you can see it snaps into place. I need to change the alignment, so I can use my Tab key to do that. And we'll place that in. Now I want that repeated in all the other 6mm holes of the same type. To do that, we'll use the pattern-driven component pattern. My component pattern is my set screw, and my driving feature is going to be my hole wizard hole. Now you see that was defined with a 3D sketch, so it patterned both sides for me automatically. We'll spin our component around to the back face. I'm going to use the Insert Components dialog box to insert a washer. That's been set up with a mate reference, so as you can see it snaps directly into place. I'll use Insert Components again and choose a screw. The screw has no mate reference, so it doesn't snap into place. Now I can get the concentric and coincident mate to happen automatically by alt dragging on the common edge between those two references. You can see that it just drops into place like so. If I select my component, from the context menu I can select View Mates, and here we can see our concentric and coincident mates. Now to repeat those components along the back face, we can use a tool called Copy with Mates. I select the two components, go to the Copy with Mates tool, and then from here what we need to do is establish the new coincident face for my additional instances. That's actually going to be repeated, and then the new concentric references. So all I need to do now is go around selecting my new cylindrical reference for the concentric. So we'll select that face, and then I'm just right clicking to move on to the next one. So you can see very quickly I can populate my assembly with all of those instances. I'll use the D key to bring confirmation corner next to my cursor and exit the tool. Now if we look at our tree, you can see all the fixing components that we brought in are all underdefined. It's because they're free to rotate. We can lock all concentric rotation by right clicking on the mates folder. I can then select all of my fixings, right click and add them to a folder. I can give that folder a name, so here we'll call it fixings. And if we go into that folder, we can see all of our components underneath. To tidy up the tree even further, we can right click at the top level, go to Tree Display, and then choose to group component instances. This groups all component instances together. Okay, so we'll rotate our component around now, and we're going to bring in a new component on the small flat face that you see there. So S key, Insert Component, and we'll select the cable housing component. I'll drop it in and we'll use Quick Mates to position it. So I'll select the two faces and make them coincident. You can see that I can flip my mate alignment at the click of a button. I'll use the right key to drag my component, which will allow me to rotate it. We'll then select the face of the gasket, launch the mate tool, and I'm just going to use the Alt key to select through the face to get the face I want. We'll then select the side face and the edge and make them coincident. And then the D key to exit out of the tool. Now this component's been set up as a smart component. To use it, I'm going to right click, insert my smart features, and it's asking me to select a face. So I'm going to select the face that I want. Now you'll see a smart component can bring through additional components with it as well as features. So if we hide away the housing, you can see it's brought through a number of components and put a number of cutouts into our part. In terms of how it looks in the tree, if we expand the smart features, you can see all the components nested underneath. We'll use the S key again and launch the Insert Components command. This time we'll bring in the motor mount bracket. Now again, to position that, I'm going to use the Profile Center Mate by selecting the cylindrical face or the circular face and the circular edge, and then choosing Profile Center from the Quick Mates toolbar. That's still free to rotate, so we'll launch our Mate tool again, and I'm going to select my fixing hole. And in the Mate command, we've got an option called Make First Selection Transparent, perfect for this scenario. Just allows me to select through my first component to the hole that I want to fix it to concentrically. D key to exit out of that tool. Using the S key again, I'm going to launch Insert Component. And this time we're going to bring through the motor. Now the motor is going to sit within the housing, which is going to present a few issues when mating. Now here I can create the concentric mate, no problem. But the rest of the mates are going to be a little bit tricky without hiding components away. Rather than hiding components, what I'm going to do is I'm going to select the motor mount bracket, and I'm going to launch component preview window. So in the right window, the component preview is launched with that component isolated within that window. Now I can select an entity from that window and the corresponding entity from the right hand window and mate those together. So just the two fixing holes there. We'll then take the face of the motor, the face of the bracket, and make those coincident. So that's now mated into place without having to hide any components away. S key again, insert components. This time we'll bring through the hard stop. I'm going to use my right mouse button to rotate the component around, select the two faces and quick mate them coincident. We'll then have a concentric mate, and I'm going to select one of the faces of the slot, one of the faces of the hole, and then from the quick mate toolbar I'm going to select slot mate. Now the slot mate allows me to define the position of the hole relative to the slot. So we'll set it percentage along slot and it's set at 100%. So that means if we zoom in, we'll see it's all the way to one side, which it is. I'll launch the S key again, insert components. And this time we're going to control select two M6 fixings. Also what we're going to do here is pin the insert component dialog box on and then just select the M6 washer to begin with. That will allow me to place my first instance and then automatically move on to the second instance. I can then switch to my screw, place my first instance, and then move on to my second instance. These have been set up with mate references, hence why they snap into place. I'm going to window select that group of components, select my standard plane, and then from the S key, launch my mirror components command. We'll use the D key to just OK that command, and you'll see they mirror across to the other side like so. We're going to use insert components again, and then bring in the gear drive housing. Again, to quickly position that, we're going to use the profile center mate tool. Here I need to flip the alignment. Again, that's free to rotate again, so I'll just use the Mate tool. We'll select our hole and then select through the component to the fixing hole. D key to exit out the mate command. We'll launch insert components again. And we'll finish with our drive motor bracket from earlier. Again here I'm going to use a profile center mate to position that. And then finally, to stop it from rotating, I'll just add a parallel mate between two surfaces. And that's our assembly pretty much complete. I'm going to use Ctrl S to save the assembly away, and we'll give it a new name at this point. Now there were some in-context references caused by the smart component. Now we get a little warning, and we can save with in-context references so they remain in context rather than become out of context with the saving of the assembly as a new name. We'll then launch our exploded view command. Now I'm going to window around a group of components from right to left, so anything touching that window will be selected. And within the explode command there's an auto space components option. Now if we drag those components out, you can see they space automatically for us, but not quite in the right order. The screws are behind the washers. That's because it uses the bounding box center as the point of reference. New to the 2020 release, we have the option to use the rear or the front of the bounding box as the point of reference. So we choose the front of the bounding box and you can see the screws now explode in the correct order. We can adjust them even further by grabbing hold of one of the arrows. Now moving on to the back, we'll window select a group of components. The ones that we didn't want to include, we'll just select them to deselect them. And again, just pull those out using the arrow. And now we'll move into the drawing environment. So we'll go File, Make Drawing from Assembly. And that will create an isometric exploded view for us automatically. We'll drag that on. You can see it's too small for the page at the moment. So we'll go into our status bar and change the scale. Using the S key, we'll insert our table. This is going to be a bill of materials. And we'll just position it in the top left-hand corner. Next up, we're going to balloon our items. So we, from the S key, go to the balloon option. And we use the auto balloon command. And within that command, we can position all our balloons from to the top or to the side. We can use the magnet line to very quickly manipulate those balloons. And then we'll just drag some of those balloons around so they don't cross each other. You can see that the magnet line automatically spaces the balloons out for us automatically so they stay uniform. Now the balloons themselves are not in sequence at the moment. To get them in sequence, we can go back into the auto balloon command and then choose to order sequentially. And if we select our first item as the left-hand item, you can see it adjusts all of those balloons and our bill of materials to suit. Within the bill of materials, we have an all uppercase option, which means that all of our text is uppercase. And if we expand the side panel, we can see the structure of the bill of materials. We can see items that haven't been ballooned, so you can see they have no balloon next to them. So we could come back, create another view perhaps, and then balloon those items. So that brings us to the end of our tips and tricks. On the following slide, we'll try to summarize the tips and tricks for you for your reference. Thank you for watching.